My name's Iheanyi Ekechukwu. I'm going to be talking about building a canary testing framework today for your distributed systems. So, reintroducing myself, I'm Iheanyi Ekechukwu. I'm a senior engineer at GitHub. My Twitter handle is @Kwechu, and that's my GitHub handle right there if you're interested in that. Let's jump into this talk. So first things first, a lot of people are probably wondering, what is a canary? And back whenever I first learned about this, I was just like, is this talking about like a canary deploy, something else? And it's actually referring to a canary in a coal mine, right? So back in the day, people or miners used to use canaries to detect carbon monoxide poisoning. Similarly, in systems, a canary is something that runs continuously in testing and alerts you to problems in your systems before your users notice them. There's other names for this, like Lightstep, which is a distributed tracing as a service product, has a good blog post about mystery shopper monitoring, and it's the same concept as a canary, so highly suggest reading that. And like I mentioned earlier, since it's like detecting bugs and user-facing features, they should mimic user behavior and test a very specific feature or functionality of a system that it's deployed for. And since we want to catch bugs in production before the users notice them, they should normally run against your production system, right? There's exception to this rule, but like generally speaking, it's just good to run them in production continuously. And honestly, this is like my personal opinion, but I do feel that with the canary in itself, each product should have its own canary. They shouldn't be all just mashed into one big monolithic canary, because that way you can do more fine-grained tuning and alerting on each of the canaries and the tests that pass and fail. And whenever you go to visualize them and the test execution status, they're not all going to be jumbled together. So, yeah. And you're just like, wait, is this an integration test? But like, yes and no, not really, right? Because if you have this as an integration test, and we gotta hit that upgrade button, you kind of get like canaries, which are integration tests on steroids. So, like, I'm really proud of myself for this one, actually. I thought about this like on Wednesday night. I'm just like, oh, I'm mad in this. Basically, what you get is like with integration tests, I feel like they're often stop at like the database level, right? Like sometimes it works out well. Like you have a lot of end-to-end testing frameworks in like Rails, Django, even in the front end. But in a distributed system context, the database may not be the stopping point, right? Actually, like in some contexts, like the way I learned about it, the stopping point wasn't a DB, it was actually a hypervisor. So this is why we need to build our own custom canary. And this is because we want to do more than just simple CRUD operations, right? Like sometimes it's just doing, oh, hey, create this resource and ensure that it was created and persisted in a database. That's not necessarily enough. So context is, I had my previous employer, DigitalOcean, I was working on networking products, right? So our canary would be able to build up or create droplets. Sure, that would be persistent in a database, but then we're able to do more with it. You can SSH into the droplets. You can run Unix commands such as like ping or even provisioning it with like Nginx. And I worked on like firewalls and our virtual private cloud project, and we're able to like test the networking traffic between droplets with multiple users and a singular user, and an integration test wouldn't have been able to do that for us, so that's why we have that framework. And other teams had like interesting use cases for canaries as well, like block storage would provision a droplet and a volume, and then SSH into the droplet and run some commands to see if it was mounted properly, right? And you don't get this from most of the integration testing frameworks that are out there right now. And additionally, right, with integration test, the context isn't necessarily as distributed. Like at DigitalOcean, we had something like 13 data centers, I believe. I may be off. But basically, these canary tests can be isolated to run in every single region. And we can also use various Linux images that we have for all of our systems. And that way, if one region is failing and the other ones are healthy, then something's going wrong with the system deployed to that region. So that's pretty important. And also, you get to you can get some very interesting race conditions caught. Like on firewalls, the canary I wrote caught that there was a race condition for whenever you create a droplet, and then you apply a firewall to it immediately afterwards, and then you get locked out of the droplet. So yeah, I don't think an integration test will have caught that, because even the test that we wrote didn't catch that outside of canary test. And since a canary is like just another service that's deployed, you can kind of get more observability into what's going on into your systems, with also having like structured logging and also like metrics into the canary framework itself. It helps to extend those. And additionally, if you're using something like tracing, open tracing, you can get see how that propagates from the Canary down to the hypervisor or whatever your services are doing. So that's really nice as well. So you're probably wondering, well, how do I even build this Canary testing framework, right? Whenever we build anything, you kind of have to lay out the requirements, right? So for the context of this talk, we gotta lay out some necessary features. First, we want to see the test output and its execution status. Did it pass? Did it fail? What's going on? And if it failed, why did it fail? And we can save this into a database, which I'll also mention later. Recording and alerting on metrics via Prometheus. Pretty much, I think it would be nice to see how many tests have failed, how many are currently running, and how many have finished running, and how many have even been started. Also, we don't want to run these tests synchronously or sequentially, right? We want to be able to run them all simultaneously, or concurrently rather. And we want to run them repeatedly, so maybe every 10 minutes or half an hour, and maybe set a timeout of 10 minutes, 20 minutes, whatever on them. And these tests should be able to be written in something that's flexible and approachable, so not necessarily something statically typed, right? And so we have these requirements, so let's break it down into the actual architecture components. For the underlying framework itself, we're going to write this with Go, mainly because this is just a pretty fun language, and where I learned how to the Canary framework I helped maintain was written in Go, so I have a lot of context around that. For the test VM itself, we're going to use JavaScript, and it's going to be embedded inside the Go framework itself. And of course, we're going to need a database for storing test execution results, and an API and a web UI for visualizing the test execution results that are stored in our database. I know a lot of you are probably why go for the actual framework? Why not in JavaScript if you're writing JavaScript test? Why not Rust? Go doesn't have generics. But, we get some good wins from using Go, right? So Go's concurrency model really helps us out here because, like we said, we needed to have simultaneous test execution. With using Go routines, we can run each test in an isolated fashion in its own Go routine, and that's pretty dope, right? And also, with Go's context API, we're able to set timeouts, and it can automatically cancel if that timeout is exceeded. And there's decent support for embedding languages. If we were embedding JavaScript, there's VMs for Clojure, and there's a VM for Lua. And at DigitalOcean, we used Godot, which is just a Go DigitalOcean API client. And if we wanted to, rather than making raw HTTP calls, we could actually embed that inside the VM itself and call it from the JavaScript. But we're not using that in our example. And it's why JavaScript for the scripting language? Why not writing it in Go itself? I think Go is kind of a little bit too strict for these nitty-gritty or these quickly written tests that we want to do to verify behavior. So JavaScript gives us a lot of flexibility, and also just made it faster to be more productive to build these tests, right? And some may argue on this, but low barrier to entry. There's a lot of prior art for JavaScript itself, and so I know some people have beef with it, but honestly, writing the tests with JavaScript was really quite nice to use with this framework. And we can embed it within Go using Auto, which is pretty clutch, right? And a requirement that we needed. So here are these core components into an architecture diagram, pardon the tiny text. Basically, starting from the left, we have the Canary Daemon, which runs indefinitely. This will also serve as an API and also serve up the web UI. This will configure the VM or the Canary with what it needs and call the test runner for each test. And that test runner will then make a JavaScript VM for each test and execute it and return those results back, whether it's passed or failed with an error, all the way back to a daemon, which then can save it into database, and we can use that to look it up in the web UI. And so if we break this down, if I have any Overwatch fans here, you'll know what I'm referencing. It said in my bio I'm a huge Overwatch fan, so had to do it to him. Let's break this down a little bit further, right? So at its core, every single test is instantiated and ran inside of a JavaScript VM. Not a surprise, it allows us to write and run these test scripts using JavaScript. If we want to add more features onto this framework or like to the VM itself, such as logging or even like HTTP support, because we're not running like a V8 like embedded inside of it, right? We can attach this to the framework itself. And we're able to do this using Auto, which is by Robert Crimmon, and it's a JavaScript interpreter written in Go. So next is up is the test runner, right? This also is responsible for isolating the VM, and it configures the VM with necessary extensions, and then just runs a test inside of the VM itself. And returns errors, if any, from that test execution. The Canary Daemon is what calls a test runner, and is just going to be running indefinitely in infinite loop. It executes a config file and then registers the test to run. And I'm probably just repeating myself, but you repeatedly run each test and save the results to the database. And it also records and exports metrics such as the test started, the ones that are running, and finished, and we use Prometheus for that. And like we saw earlier, it also can serve up an API in the front end. So it's a lot to take in. So let's actually look through some code in like this framework itself. And you know, we're talking about canaries. It's got a nice little Birdman hand rub right here. So let's get into this code. And in the words of Young Jeezy, let's get it. Yeah, so let's talk about loading these test configurations first and foremost. Here's a function in a config package that we're using to load a configuration file for each canary. As you can see, it takes in an auto VM as input, which is just our JavaScript VM. And then it takes in an IO reader, which is just a file. What happens next, or it's an open configuration file. Then we're also instantiating or defining some functions that we can call from within this JavaScript VM, because you see config VM.set. And let's see here. We're going to walk through these auto functions a little bit. But this context object is actually really important because it's the first thing that happens after we copy our VM. The shape of it is that it has not only a config object that takes in a name, it's an array of test configs that are going to be our tests that we actually run, right? And these test configs have a name for them. They all have a frequency that they should be run at, and they also have a timeout for like when they should stop executing. And also they take in an auto script, which is a parsed JavaScript file used within them. So now that we have that out of the way, let's actually take a look at these two helper functions that we're defining here. They're called file and register test. And these are basically helper functions that we can use inside of our JavaScript itself. So autofunc file is actually setting a function definition on the VM itself. It'll take in one argument, which is just going to be a file name, and then using Go underneath the hood, we can actually open the file and parse it into a string and then return it back in the JavaScript. And this will get called in conjunction with register test, and we can look at that one next. With register test, the shape of this function is kind of different. The first argument is actually going to be an object. The second one is going to be a source, which is just a string of the JavaScript to actually execute for that test, right? And something to notice is that, well, actually, I'll get back to that. Let's go to this config.load because it's actually important. So these are actually two very interesting lines here. Basically, this config.load function is taking the input, and then what we're doing is mapping over that JavaScript object and its keys. And basically, you define what keys you want from it, and you're extracting that value of that key into the Go config object underneath the hood. And we passed a pointer, or you can see like on the first line underneath the comment that we have a reference to a test config instance, right? So it's just mutating that instance of the object underneath in the Go program. And then going back to this, we can see below the call to source, we're just instantiating that into a test config object with the name and the frequency and the timeout. And we're compiling the source script into an auto script and saving it into that instance of that test config object. And then we're just appending it to the list of tests and under the hood. So now we're back to this config load function, right? We have that all set up, like that was just the helper functions underneath the hood. Basically, from that, we're going to call a reader on the file that's passed in, which is just going to take that source config object, and then that's going to actually run the script inside the config VM, and with all those helper functions defined, we'll then be able to return the context configuration, or the config object, and also its array of tests that have been created. So if we look at an example config.js file here, right, we have a frequency defined of 10 minutes, timeout defined of 10 minutes. Register test is that function that we defined in that helper function, and it takes in the name, which is a simple example test, our frequency and timeout, and those are all in the object. And then you see that file function that we defined in the VM as well, which opens up a simple example.js file, which is just a test script in this case. And this is all gets stored in the underlying Go execution environment, which is pretty dope. And just like, that's cool, but how this even gets called, we're going to create our daemon file and call this function. So let's say we just had this empty main file. Also, I left out package names and imports because there's only so much line height in a slide, so bear with me, y'all. Go format, got your back anyways. So if you look at this main file here, what we're doing is we're basically instantiating some flags to use with our Canary Daemon, the config path, the working directory for our test, and then essentially we're creating an instance of the auto VM, and we're just calling must load configs on this VM and with the config path itself. Must load configs attempts to open that file name that we pass in, and then if it throws an error, maybe it doesn't exist, it's just going to fatal, and it's just going to exit your program, right? But other than that, then we're calling our canary load function, and we got our canary configuration and its array of tests that are running with it as well. And we get to return that back up to the main function. So how do these actually get running, right? Well, now we can actually look at the test runner logic. So we're in a different package again, so keep this in mind. But the logic for running the test is actually pretty lean in comparison. We basically start off by making a copy of the VM, so the test run is actually running in isolation by itself. And this Go routine that we're starting is actually being used to detect if that context has a deadline attached to it, then basically if there's anything called or it times out, it'll interrupt the VM, and that VM will return an error back to the run function. And then we can just call that test VM that we copied, call run on it, and if it throws an error in the underlying VM, we can return that back to whatever's calling our run function and close that done channel. And yeah, we're cool with that. But right now, the way it exists, we don't have any niceties in it, right? We just have an ES5 interpreter, which doesn't necessarily ship with anything like XML HTTP requests for making HTTP calls, unstructured logging, and not really anything useful, right? So let's add some extensions and extend this VM a little bit, right? Whoops. So let's take a peek into adding some standard library functions into this VM. Similarly to our config.load function, we can define a load standard lib function here, right? This is to help some standard library functionality for usage within the VM. Right now, it takes in a context, our VM, and a package name, which would probably be standard or whatever you want to call it. And what it's doing after that is it's creating an empty JavaScript object as an auto value. And then what it's doing with that object is that it's converting it into an underlying Go auto object. And then what we're doing after that is that we're making a bunch of sub-packages and looping through them in order to create these new, or to attach these functions onto them. And I'm just going to go deep dive into the OS package first. Basically, we make this OS package struct, and it has its load function called onto it. And then with that autoutil.to package call that we have here, we have this getEm function defined on that OS package, right? And as you can see in that getEm, similarly to before, like we did with file, basically we're able to extract a key that's being passed in as input to that function. And what we're doing is using the underlying Go getEm function from the OS package to then return that back to our JavaScript VM. And it's pretty dope. And this is how it would be called from within a JavaScript like Canary test, right? This will return that key of whatever it's defined with the daemon from it. And this was useful in the context because we used Kubernetes for deploying things. We had secrets or environment variables defined there, so to be able to extract those secrets from there. And it worked out pretty well. Another thing that we need is like HTTP support, right? So we want to make some network requests. The shape of this is similar to the load standard lib. It takes into VM, a package name, an HTTP client, and a request configuration for the HTTP client, right? Then we can instantiate an instance of this HTTP package and load its helper function into the VM. And in this case, we're going to define a do method onto this HTTP package. And I hate that I have this much code on it because it's like microscopic. But basically, the shape of this API is that it's going to be 4 inputs to the do function. The first one is going to be a method, get, post, put, options, delete, patch. Second one will be a URL. The third input is going to be a header object. And then the fourth one is going to be a body. And then basically, we're just going to we're using the underlying HTTP client attached to that package in Go to make a client.do request. And that returns back the response object. And we can return back to the JavaScript status code, the headers, and a body. And this is how it looks like whenever you call it from a Canary script. And by default, console.log is unstructured in JavaScript, right? There's no structure to it at all. And that's not really good. Like, you want to be able to filter and query on things, whether you're using like Elk, Timber, Logstat, whatever people use like for logging. So we're going to add a little bit of structured logging to it. And it's actually a wrapper around Logris, which is a Go structured logging package. And like similar to before, we're taking in a VM, another package name, and a field logger. This logger struct just has a field logger as one of its attributes, and basically has just an interface that's exported by Logris. And once again, same thing that we've seen before. We're adding support for 4 methods. Key value, KV, is just basically allowing us to attach key value pairs to our log lines. Info logs with the level of info. Of course, error logs with the level of like error. And then fail will actually log with the level of error, but then it'll also throw an error so the Canary test stops running. And I'm just going to take a look at KV, info, and fail. So this is kind of a long method as well. I know, I goofed. But basically, it's 2 shapes that this API could take. Either you can pass in an object to it, and basically it's just a JSON object, general key value, or you can have 2 strings or like a string and a value just for a singular key value pair as the function inputs. And this is how info looks, like it's been doing before. Basically what we're doing is that we're able to call, and get the message from as a first input, and we're just calling the underlying logger using, or calling the underlying logger's info method, and we're just returning nothing because of no op return. Fail does the same thing. Otherwise, we're calling error, and then we're throwing an error in the VM. And here's an example about how we can use this within our Canary test with one of the first API, or one of the singular key value pair API. Whew, dang, all right. So let's add them to the VM in the runner, right? Basically, below our test VM.copy, if we have all of this good stuff passed in, like essentially what we can just do is just call all of these functions with the context in the test VM. For a standard library, we're just going to give it like the package name, like standard or abbreviated. HTTP, just going to call it HTTP, and log, of course, going to be log. And yeah, it's pretty dope. And now we can add the runner to the daemon. Got to go fast. Let's see. So in here, what's really changed about this is after we load our configuration from earlier, we can actually call launch test method, right? Let's see. This will take in the VM and a Canary config, and then an array of tests. And also, afterwards, we have a select block, meaning that it'll block indefinitely and never return. And that's what makes it a daemon. So now that we have launch test, we can actually call this go run test forever, or my bad, we can call run test forever in a go routine. And we're going to dig deeper into that. So here we can see that in this run test forever, what we're doing is we're making a unique ID for every single test. And then we're able to create a new context for each test that runs. And like I was talking about before, like with the VM, we're having that duration or that timeout from every single test loaded into a test configuration, right? So for every single test configuration that we have, we can make a new context which, and call with timeout, which sets a deadline. So if it runs any longer than like 10 minutes, if that's our like timeout, right, the test will fail. And it'll throw an error saying deadline exceeded. And then we can just call our underlying runner, that run function, which will then execute the canary test. And yeah, if it throws an error, we can log that error out. And then at the end, very end, we're calling the time.sleep, because we want to run it every 20 minutes. We're just going to sleep for 20 minutes until the next execution time. And so we have all these tests running now, right? And now we want to actually save our results to a database. I finished building this framework on Sunday. It's so grimy. So I didn't want to deal with SQL migration, so I just used Bolt, which is a key value database for Go. This is how the interface looks like for the canary test. Essentially, we want a way to start test, end test, and get a singular test, and also list all of the tests that we have in our database. And this is the shape of the test instance models that we're using within the database storage. Basically, things that we've seen already, ID, name, when did it start, when did it end, did it pass? If it didn't, why not? So fail cause satisfies that. And basically, we're going to implement this interface using a Bolt store. It wraps the underlying Bolt DB, and then it also adds an ongoing map, which is just tests that are currently running, and a mutex for thread safety, and a cancel func for just other timeouts. And so for start test, we're actually not writing anything to the database yet. It gets stored in that underlying ongoing map. And it's just stored in that map with its ID as the key. And then when we call end test, we can go into that map, extract that test instance from it, and then delete it from that map, and then also insert it into our Bolt database or data store. And basically, this insert test is just what is saving this test instance into the actual database. And we can add this to the JSON. We'll add a flag for a DB path to our configuration. We'll also make a new call for instantiating a database and passing it down to both launch test and run test forever. And basically, most open Bolt is just simply like making a new instance of our Bolt store and returning it back to us. And I know this is microscopic, but you can see before or after we define the context, you can see that we're calling start test. And then after the runner returns, we can just call end test and pass in like the test that we originally created. And yeah, then it's done. And if we have our tests running continuously now, like we need a way of visualizing the results from like the database. Honestly, I was going to build a React front end for this, but your boy ran out of time, so I decided to go with the GraphQL. So we're going to use GraphQL for our API because, like, all the cool kids are using it nowadays. And we're going to use gCodeGen, which is kind of one of the newer Go GraphQL libraries. And essentially, we can make a GraphQL application using gCodeGen to serve up everything. And essentially, it makes two handlers: a query handler for the actual the actual queries, and then just one for the GraphQL playground. Our GraphQL schema is a one-to-one mapping to our database model. And you can see our queries are like test, singular test, and then tests that are currently ongoing. And then we have our resolver methods for everything here. So basically, this is calling that underlying Bolt stores methods that we saw in the interface to list all the tests or get a single test or get the ongoing test. Not too bad. Back to the daemon. we're going to make a new function called launch HTTP after we instantiate our database. And this must listen function just really creates a listener, a TCP listener, and that just joins the host and port together. Oh yeah, we have a listen host and listen port at the beginning. There are new flags. Launch HTTP creates a new instance of that GraphQL application for our front end, and then it just launches it in a Go routine so it doesn't block the main thread. And it just will run in the background. And since our daemon runs indefinitely, that HTTP server will stay up. And since I didn't have time to build an actual front end, we can actually use like the GraphQL playground, and God, the contrast in this is terrible. And then you can see the test execution results. And then last but not least, we got metrics. So good old Prometheus. This is going to be a quick one. Essentially, I start off by making, we can start off by making a metrics package. I have a really grimy abstraction around like the Prometheus register. And we can register other metrics like the Go process collector and just like memory and all that good usage. And it also returns a handler for our metrics itself or themselves. And so inside of our Canary Daemon, we'll instantiate this node, right? And we'll pass the handler into the launch HTTP function and the metrics node down to our test runner. In launch HTTP, we're just actually going to use this new handler to be mounted at the metrics subpath on our HTTP server. And they're going to be exported for scraping using like prom alert. And then in our run test forever function, we can define a few like, let's see, 2 counters for started and finished, and then a gauge for running since it will fluctuate up and down. And also note that we'll have a result label attached to our finished counter. So then for our test execution, right, this changes up a little bit. Whenever we start a test, we can call the started counter and add 1. For running, we'll also add 1, but then we'll add a defer, which then like will with a -1, so it fluctuates up and down. Then after it finishes running, we can say, okay, if it finished and it had an error, it's going to be a fail, right? So we can like add 1 to our finish counter and give it a label of fail for the result. But if it didn't, it's going to be a pass, so we can add that label instead. And then if you go to the metrics path on like in the browser, you can see those are our Prometheus metrics, and you can see various things that are running in the test names and all of that good stuff. And we're done. I'm gonna see if I can demo this right quick. Let's hope this works out, because you know how that goes. So here, it's like, how do I exit Vim? I'm playing. Oh, wow, Keynote just quit. So let's open up a canary test. I'm gonna open up simple http.js. And basically, we're just gonna use our HTTP method that we defined earlier. And it has a do method. We're gonna use a get. We're gonna call iconhasip.com, because I didn't know what else to call. And we're going to return or log out what the test output is, or the output of the response in a key value pair. Oh, yeah. Enhance. So yeah, that good? Thanks, no problem. Whoa. Okay, this one, so now if we like restart it, I'm gonna start my Canary Daemon. And if you look at the very last line, right, we can see, here we go. We can see like, okay, we get the body returned, and it basically returned just the IP address. And it's structured logging, so you can see the key of body that we used and what it output as well, and the name of the test and its ID, and the log message as the first value. And then also if I go to my browser here, here we go, and we query, you see we have a test called always fail. We can get the logs back from that, or the fail calls from that. Always fail, always fail. Icon as IP, oh, that one threw an error. No such host. And then you get simple example test, nothing, it passes. And just for posterity, I'm gonna show always fail here. Basically, always fail will always just call log.fail and always error out, you know? Obviously. Let me see. Let me get back to my slides. Oh, Keynote crashed. Cool, dude. Extend desktop. All right, yeah. I put the code up on here at Simple Canary. I haven't written a README, so yeah. And there's no test, but hey, it works. So yeah, I'll get to that eventually. But yeah, check it out. Wait, hold up. Thank you, y'all too kind though. I want to thank Antoine Grandin. Back whenever I worked at DigitalOcean, really good friend of mine, mentor, friendtor, whatever you want to call him. He originally created like the Canary framework at DigitalOcean, and I actually just got tired of bugging him all the time, so I started helping him maintain it. But he kind of taught me how canaries work and their functionality. And yeah, he also gave me like the go-ahead to give this talk and like pass his knowledge on to y'all as a proxy in a way. So yeah, he's awesome, and I wanted to thank him, even though he's not here. And questions. I'm going to switch to Slido while this slide is up, if y'all don't mind. Unless there's somebody from the crowd that has a question. What's up?
We feel like is the tipping point at which the overhead for doing this is worth building it. This looks awesome, but I'm trying to figure out like approximately how much testing and maybe some good.
You'd be surprised. So I think it all depends, right? Because like whenever I worked at DigitalOcean, like I was working on networking products, and like this framework for an example use case is like we could spin up one droplet here, SSH into it, spin up a separate droplet, SSH into it, apply a firewall policy that lets like, I don't know, TCP traffic over port 80 through, and then on that same droplet that has that policy, we can install Nginx, which automatically has like its default page serving up on like that IP address and port 80. Then that second droplet, we can then SSH into it and exec a command to, like a curl command, to curl that IP of the other droplet and verify that the page is returned back. But I think like, but there's a lot of things that we had to verify, and even with virtual private clouds, we had two users, like with separate API tokens, but we want them to spin up a droplet with private networking and another one with private networking, and then verifying that their network traffic can't talk to one another. It's like kind of like, it seems like overkill, but honestly, it's like since it's all security-based products, like we didn't want people to be like, oh my God, why can they like spy traffic or something like that, you know? So I guess it like all depends, right? Like it all depends on what like your problem space is and what you're working on. But it's like, we were talking about integration testing is like, well, we can't use the API. Who wants to actually write bash scripts to do end-to-end testing verification? That's not like scalable. And just give us way more flexibility. So it depends. Like I know that's a very broad answer, but yeah. Let's see. I think somebody else had a question. What's up?
Say that like canary tests are like more or less like acceptance tests that you have running against production, or is it kind of a separate category?
I'd say so. I think it sounds about right. Yeah. I mean, you're trying to verify that user behavior is like as expected. Personally, I always thought about acceptance tests as being like something, whatchamacallit, what's the word I'm looking for? Like UI driven, but all of our canary tests are like API driven because at least the ones that in the context of DO, and that just was for like, I don't know, problem space reasons. And we, but yeah, they are a form of acceptance testing as well. Oh, let's see. Somebody else had a question? Oh yeah, what's up?
Do you have any best practices for managing side effects of the services you're testing? Like maybe there's some counts on impressions or side calls that actually change data stores and things like that.
So,
You call it your canary a service.
yeah.
Service, and it's doing things to other services.
Yep. So wait, I'm confused. Could you repeat that?
So sometimes if you're in a microservice environment,
Yeah.
you might want to canary a single microservice.
Mm-hmm.
That microservice is driving a whole tree of other things.
Mm-hmm.
And those things may be changing the state of the world, like incrementing a counter in a key value system.
Yeah.
So when you're canarying, you wouldn't want to be creating these side effects.
Oh, I'd argue you would. I don't know, because like a canary is mimicking a user itself, right? Like, in the use case I had, like, we didn't have to necessarily increment like a specific, we didn't have any like global state like that, although like they're pretty isolated contexts. But also the canary does help seeing like for each service, like if something does go wrong in another service, like and it goes down, it can propagate back up to the UI or like to the canary itself. So it all depends. And I had one question on Slido. It's talking about canary releases and deployments, proxying, routing percentages of traffic, nothing else. For Canary, well, it's not Canary releases, but for our Canary, we just literally deployed it to our Kubernetes cluster with a scale of 1 because it's like just a single context. And no percentages. We will just like hit production and hope for the best. And I think I got time for one more question if anybody has one. What's up, dude? Like anything, I think there was something on the server side, like we had like user IDs for, like we had Canary specific users, so we could filter those out from like analytics as necessary. But also, it depends, because I'm not sure like at that case where we had like analytics at the API level, or at least the public API level, but I do know that the UI had went through a different API, like an HTTP or JSON API that the Canary would never talk to, so that also helps. All right.